Good morning.
Good morning.
How are you on this wonderful day outside?
I am doing really good. How are you doing?
Good. All right, let's pick up. Let's see, last time we left off with this problem here.
Okay.
I know these are very hard to read. Let's see. This is a rectangle, and this dimension is 4. This dimension is 5, and this dimension is 12. And this is B, E, and C, and D, as in David. So the first question is BED. The first question is, what is the area of that triangle?
Okay, and that would be 1/2 base. And let's see, since I have the 512, the other side of that's going to be 13.
Okay.
So I'm assuming that the area of BED would be 1/2 13 times 4.
Okay, it's the base times the vertical height, not the slant height. In other words, you would not use this as the height of that triangle. You would use this. Can you see where I'm pointing?
Oh, no, actually, I don't get it. I was thinking it was the shaded area is what we were looking for.
It is. And there's the base, 4.
Okay,
but
that's
the height is the vertical height. In other words, the perpendicular height. If I draw this triangle, okay, in other words, if I rotate that 40 degrees so that that's the base, the height of that triangle is this vertical height right there, which in this case is 12.
Okay.
Okay? You are correct that this is 13, and we're going to need that for the next question. But this is the figure we're looking at here, where this is the shaded area. Okay? So the next question also applies to that figure. What is the perimeter of BED? BED. So now we not only need this 13, but we need this dimension over there. In other words, line BD.
Okay. And it looks like I would need to use the Pythagorean theorem.
Notice that to solve for BD, we're looking at triangle BCD. And BC is 4 plus 5, that's 9. This is 12. That is also a 3, 4, 5 triangle.
Okay.
So X would be 15. So now what's the perimeter of that triangle?
Okay, and I'm looking just for the perimeter of the shaded area?
Yes, the perimeter. They want the perimeter of BED.
Okay, so it'd be 13 plus 4 plus 15.
Yeah, what is that? 32?
Okay. 32.
Okay. Now, the following two questions apply to this situation. Same kind of deal. What's the area of the shaded? Let's see if I can figure out some dimensions here. Let me draw this. Be a little actually, you know what? I have drawn it. Let me just relabel it. All right, this is 7. This is 3, surely. I'm having a hard time reading it. This is 5. And the whole bottom is, what the heck is that number there? Oh, that's a letter. That's H. Okay, so I think that's all we know. And they're going to ask for the area of this, so we need HF. This is HF, and this is D up here.
Well, I'm assuming D to H would be 4.
Because that's a 3, 4, 5, right triangle.
So H to F would be 3.
Okay, now what's the area of that triangle?
Seven, 1/2 7 times 3.
Okay, hold on. We're looking at the shaded area right there.
Okay.
So the area is 1/2 base times height. What's base?
I'd say 3.
Okay. What's height?
Or 3.
Okay. So 4.5 is that area. Again, it doesn't matter whether these triangles are lying on their base or not. In other words, in this case, yeah, it was easy to see that HF is the base. But in the other triangle, the base is this one over here. It's the vertical measurement.
Yeah, that one I'm still a little confused on.
Okay, well, it's the same as this one, only this one has been rotated 90 degrees. If we look at this one here, the second one, notice that this is the base, and we want the vertical height. We don't want that 5 height. We want the vertical height. It's always the vertical height. Same way in a parallelogram. Let's talk about parallelograms for a moment, because we're going to get to them today anyway. If I take the area of this parallelogram, it's the base 4 times this vertical height, not a slant height. In other words, it wouldn't be times 5 for the area. It would be whatever this vertical height is, 3. Same thing for a triangle. It's always the vertical height. Okay? So let's go back to this one. This is not our base. This is not our base. Neither BD or DE is our base. BE is our base.
Okay.
It's just not sitting on the base, but that's okay. That's not the definition of base. You can use base as any side you want. I could use DE as the base. The problem is I don't know that it's vertical height here.
Okay.
I could use BD as the base, only I don't know that vertical height. But if I use BE as the base, then the only thing I need is the vertical height, which is that measurement right there, which is 12.
Okay.
Okay? Okay, and the next question applies to the same triangle, so I will leave it up. What's the perimeter of DFH? So we know this side is 3. We know this side is 5. We need the measurement of DF. I know that side's 3. So this is a Pythagorean equation solution.
Okay.
You want to be able to do these quickly. Okay? If I give you a right triangle and I give you two sides of that right triangle, in this case we have a 7 and a 3, you want to be able to get this rather quickly. You don't want to have to say c squared equals a squared plus b squared. This must be c, this must be a, this must be b. So I can work out how to solve for c, but it's better to have this memorized. I think I've mentioned this before. C,
Yes.
the hypotenuse, is always what? Always starts out with square root, whether you're solving for the hypotenuse or one of the sides. In other words, if I'm solving for a particular small side of a right triangle, my answer is still going to be it's the square root of something. Okay? In this case, since the hypotenuse is the longest, it's the square root of the sum of the squares. If I was solving for side A, it would be the square root of the hypotenuse squared minus the other side squared. Here's the two formulas you want to memorize and be able to go immediately to those, merely because you have to do it so often. Granted, more than half the triangles we've seen have been 3, 4, 5 or 5, 12, 13, so that'll get you far. But it won't help you with problems like this, since this is not a perfect Pythagorean triangle. So let's use this one here. So what does C equal to?
Square root of 58.
What's the perimeter?
It's 8 plus square root of 58.
Okay. Oops, hold on. I'm trying to move this over. There we go. Hold on. Let me use my mouse to do it. I have more control with it. Okay, which of the following expresses a true relationship between x and y? This is 3y, 2x, and x.
It would be 180 minus 3x equals y.
Okay, it's easy enough. This problem here, what's the perimeter of ABC? And like an awful lot of problems we're seeing, it's a question of filling in the missing measurements. And usually they're not going to be direct. You're going to have to figure out something else before you're able to figure out the one you want.
Okay, and it looks like A and D would be 12.
Solve that triangle there. since we need the perimeter of A, B, and C, we're going to need DC and we're going to need AC. So you have enough information on this ADC triangle to solve for both sides.
And I'm not seeing it.
Okay. Here's the triangle, of which we know that side. What is our unit 3060 triangle's dimensions?
Oh, it's going to be 1 square root 3 to 2.
Okay. In other words, these two triangles are similar. Because they're similar, all of the ratios are going to be the same. So what would the hypotenuse be?
It would be 24.
Because the ratio is 12 to 1. What would this side be?
12 root 3.
So we've got 12 root 3 there, 24 here. Now what is the perimeter of ABC?
It would be 48 plus 12 root 3.
Correct. Okay, that was a good problem because it illustrated almost everything we need to know about their geometry questions.
Okay.
We needed to know either the 3, 4, 5 right triangle or else how to solve for that using the Pythagorean theorem. And then, more importantly, we knew how to solve this 30, 60, 90 triangle. And you're either going to need to know how to solve 30, 60, 90 or 45, 45, 90. Those two. Those two, you really want to know those unit triangles. What's the 45, 45?
It's 1 square root of 2.
Okay. And if I have another 45, 45 over here, whose dimension is 3, what's the sides on this one on the left?
1 over root 3. Oh, root 3. I saw 3. Square root of 2.
Okay. What's the first step we're going to do in solving that? Find out the similarity ratio. What's the similarity ratio? How much bigger is each side of this triangle compared to our unit triangle?
Well, wouldn't it be 3 square root 2?
3 divided by square root 2.
Yeah, that's what I was trying to say before.
Okay, but that's different than that.
Okay.
Okay, this is 3 square root 2. Okay, now let's see. If I rationalize this, what do I get? I get 3 square root 2 divided by 2. Is that what you were saying the first time?
Yes.
Okay, sorry. I didn't understand. But that critical step here is dividing this number by that number. In other words, the only two known corresponding sides. And that's a difficult step for some people to make just because they don't like handling irrational and whole numbers at the same time in that ratio. It's not as pretty as when this was a whole number and this was a whole number. All right. And let's see, there's one more question referring to this. What's the area of ABC?
Okay, so it's going to be 1/2 base, which is 9 plus 12 root 3 times 12. So 54 plus 12 root 3.
Okay, make sure you distribute both this number to both of them. In other words, you can take the 12 and cancel it with the 2 and turn it into a 6, but now this 6 has to be distributed to both the 9 and that. So it would be 54 plus 72 root 3. Okay?
Okay.
All right. I guess next page here. 239. Wow, where was that page? Okay, 16. Or this top one here. Uh-oh. What's the rule about any side of a triangle?
What's the rule about any side of a triangle?
Yeah, at least that's the way I like to call it. The sides of any side of a triangle has to be, now I have one way of memorizing it, but I think you quoted it in the reverse to me, which is fine. You can memorize it however you want.
I have bigger than the difference and smaller than the sum.
Okay. Doesn't matter which order you put it in. Bigger than the difference and smaller than the sum. So the third side of this triangle has to be what?
Let's see, bigger than the difference, smaller than the sum, so it has to be between 4 and 18.
So is it bigger or greater than quantity B?
It's greater.
Right, because it has to be greater than 4. It
Right.
cannot be equal to 4. You can't have a 7, 4, 11 triangle. It would actually just be a straight line. Okay, shut my camera off. It's complaining. The ratio of the length of a diagonal to the length of the side of a square, or root 2.
And it would be equal.
Okay. Perimeter of this triangle, or 30.
And I'm having a hard time seeing that. Is that 10 and 10?
Yes, sorry, that's 10, 10, A, B, C.
Okay.
I don't blame you. I'm having a hard time seeing it on my end, and I got a full screen view of it.
Quantity B would be larger.
Okay. I like to try to solve this problem visually
Okay.
by altering this angle. In other words, I can make BC much bigger than 10, right? I could easily make it 12. But if I make this angle small, I could also make BC short. In other words, this would be the side 10, this would be the side 10. I could certainly make that 8. Or if I draw it like this, well, this side clearly is more than 10. We'll say it's 15. So in one case, I got a perimeter less than 30. In the other case, I got a perimeter more than 30.
Okay.
Okay?
So it can't be determined.
It can't be determined. I'm curious as to how you did it.
I didn't do it. All I was thinking was bigger than the difference, smaller than the sum. And I didn't think about the fact that smaller than the sum would be about 20.
Okay, I got you. All right. Okay, we have two questions that are going to refer to this figure, and this is particularly hard to see also. That says x degrees. That says 5, and that's AOB. And is the length of AB greater than or equal to 7? And this down here says that x is greater than 90 degrees.
A would be bigger.
AB?
Yes.
Okay. That's correct. You just figured out based on a right triangle?
Yes.
Okay. And this based on x being equal to 90 degrees, AB was bigger than 7. And so if x is greater than 90 degrees, AB can only get bigger.
Right.
It's another of those problems where you kind of have to do the math based on x equal to 90 and then relate it to there.
Yeah, I was really glad that you told me to do that because it's made a lot of the problems a lot easier.
Good. Oops. And this is referring to the same problem. Oops, no it's not. 20 is. The perimeter of triangle AOB, or 20.
Okay, won't they be equal because they're both equilateral triangles?
Sorry, this is not 21. This is problem 20 that refers to the figure from the previous problem, which is over here in my drawing.
Oh, okay. Sorry.
That's all right.
The perimeter would be smaller. Quantity B would be larger.
Good. In other words, you're graphically opening up angle X to where it's as big of a triangle as possible, and AB has to be less than 10.
Yes.
AB can never be 10, even if it was this triangle right here. Okay. Now 21.
And that one, sorry, that one I was saying would be equal.
Okay. Here's the equilateral triangle whose sides are 10. And here's the equilateral triangle whose altitude is 10. If we look at this triangle right there, what must that hypotenuse be?
I'm sorry, I totally lost my train of thought
okay.
here.
Okay. We have this triangle. We have this triangle. Go ahead.
Well, I was going to say the base would be 5.
Okay.
So it'd be 5, 10.
Actually not, because this is a 60-30. So the relationship is not 2 to 1. It's
No, I was just mentioning the ones that we've got, the two that we have, 5 and 10.
we don't have.
So I'm actually,
we don't have a 5, is what I'm trying to say. This is not 5.
oh,
This would be a 30-60 triangle.
okay.
So this would be the square root of 3 side. But more importantly, it's important that you recognize what the hypotenuse is going to be. Is the hypotenuse going to be less than or greater than 10?
Greater.
Always. Since this side is greater than 10, 10 plus, then the area of this triangle has to be bigger because each side is bigger. They're both equilateral triangles, but what we really have is one that's this and one that's this. And this has sides of 10, this has an altitude of 10. It is not necessary for us to come up with that number or this number. We can, if you want to use similar triangles, but notice that it involves that comparing a whole number with an irrational number. So the ratio would be 10 divided by square root of 3. So it's going to be some complicated arithmetic to come up with that hypotenuse. But you don't need to, nor do you want to. You merely need to recognize that it's got to be bigger than 10. And once you figure that out, then the area of the one is clearly larger than the area of the other. Okay, so we have a 4 by 4 square that's broken up into smaller squares equally. The perimeter of the shaded region versus the perimeter of the square.
Well, I'm thinking that, let's see, the shaded region actually has 1, 2, 3, 4, 5, 6, 7 total squares. And the perimeter of the actual square has 1, 2, 3, 4, 16. Is that correct?
Mm-hmm. Although I'm not sure you did the inside. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 edges in figure A. In figure B, the perimeter of the square is 16. So what is the measurement of each diagonal, since we have 12 of them? And they made this relatively easy in that that's 1 and that's 1. So what's the measure of that diagonal? What kind of triangle is that?
It's going to be square root 2.
Okay. So there's the perimeter of figure A, there's the perimeter of figure B, which is bigger.
So A is larger. A is larger.
A is larger by just a notch. Okay, and let's see if I can figure out how to do this. Let me just, the area of the shaded region, the area of the white region.
Okay, what am I looking for?
Which is bigger, the area of the shaded region, the area of the white region?
On the same figure?
Yeah, this figure, that it should still be visible here.
Okay, yes.
Okay. Yeah, if you look at the question, there's the area of the shaded region, the area of the white region. Let me put the figure back up. Okay.
Well, off the top of my head, I would just, without figuring it out, I would say that the shaded region, the area of the shaded region would be larger than the area of the unshaded.
Right. And this is one you can do visually without mathematics. Half, 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 half. All around the outside squares, it's half and half. Equal. But these four inside squares are all shaded. So when I first looked at this, I thought they were equal, and then I noticed that the inside squares were not half and half. They were all shaded, so the shaded has to be bigger. Okay, let's see. This is angle ACB. That's 145. That's 125. Which is bigger, A plus B or C?
And my first inclination is to say A plus, well, wait a second, let's see. A would be 180 minus 145. And B would be 180 minus 125. So let's see, that would be 90, they're equal.
Okay. Quantity or PR or QR?
Okay, well, let's see. PR would be greater than QR.
Because
That's 70 and the other is 65.
so which one is larger?
PR.
The side opposite the largest angle is always the largest side. In other words, QR is going to be greater than PR because angle P, the angle opposite QR, is larger than angle Q, the angle opposite PR.
Okay.
Are you with me?
But I thought it was P times R and Q times R.
Ah, no. It's the line segment PR. In other words, it's the dimension. If this was X, Y, and Z, which one would be largest? Y would be the largest, followed by x, and the smallest would be z. In other words, we can't tell what the dimensions are, but we know which is the largest side of a triangle based on the largest angle.
Okay.
Now, some people have a little bit of troubles with the opposite angle.
I do.
You do? Well,
yes.
Just the side that is opposite an angle is the side that is connected by the two rays of that angle. In other words, I make up this 65-degree angle with this ray here and this ray here. So whatever side connects those 2 points, that's the side opposite that angle.
Okay.
Okay? Even if you have strange triangles like this, we'll call this angle A, B, or C, and we'll call that X, Y, and Z. What is opposite angle A? Which side?
Z.
What's opposite angle B?
X.
Simple.
Okay.
Okay? Where it's most applied is when you have an isosceles triangle By that information, I know that angle 1 is equal to angle 2 because these sides are the same. So the angles opposite those sides have to also be the same.
Oh, okay.
Okay? Okay, that's it for triangles. 25. Hold on a second. Yeah, that was it. Quadrilaterals. Four-sided objects. That's the definition of a quadrilateral. Now, specifically, they're going to want you to know about rectangles, squares, parallelograms, and trapezoids. Hold on, I'll get this right yet here. Okay. If the length of a rectangle is 4 times its width, and its area is 144, what's the perimeter? What's the
Okay, well, let's see. Area is length times width. So area would be, let's see, 144 equals 5W?
Yeah. Or you could say this is 4x and this is x. If I make this 4x and x, then the length is 4 times the width. So now you can say 4x squared equals 144.
Okay. So it would be 6.
Okay. So this is 6. This is 24. So what's its perimeter?
It would be 60.
Okay. This is a square. What is the area of this quadrant, or this part of the square?
Well, I know the one side is going to be 2. All the sides of the square are going to be 2.
Okay. So that's 2 from D to C.
Right. And then the diagonal would be 2 root 2. So D to E would be half of 2 root 2.
Okay. Is the problem getting any easier?
No. Yeah, actually it is.
In fact, it's getting harder.
Yeah, it's like,
There's 2 ways we can do this. The quickest is to know that each of these are equal.
okay.
What's the area of the square?
4.
What's the area of this little one?
Oh, 1.
Okay. That's the quickest. The second way is to look at that bottom little triangle, know that that's 2, and know that this is 1. So half base times height would also get you 1.
Okay.
But solving...
Yeah, the way I was doing it was going to take forever.
Well, yeah, you're going to get the diagonal, which was square root of 2 over 2 times 2. So just square root of 2. And then you would be able to solve for that height based on that. There's a number of ways you would have gotten there. Kind of try to look for graphical solutions. I've noticed that we've come across a number of problems here that have graphical solutions where you really don't need the math. As long as you know that these diagonals, first of all, that splits the square in half, and first of all, that one splits each remaining triangle in half, so that all 4 of those have to be equal.
Okay.
And what is the perimeter of that same? Now we get to see that effort was not wasted. This is 2. What'd you figure this one out to be?
It's going to be half of 2 root 2, so it's just going to be root 2.
What's this side over here?
Also root 2.
What's the perimeter?
It's 2 plus 2 root 2. Nope.
Yeah, answer D. Yeah, 2 plus 2 root 2. And that, incidentally, is always the proper way to write it. It's not to convert that to a decimal and make it one number.
Okay.
This is simplified. It's the most accurate way to represent that number. Okay. Well, quadrilaterals, all of a sudden we're going to be talking about 5-sided polygons. Well, that's interesting. If the angles of a 5-sided polygon are in the ratio of 2 to 3 to 3 to 5 to 5, what's the measure of the smallest angle? What do we need for starters to know?
The total
Okay.
degree measure of
all 5 angles. What is that?
right. That would be 5 minus 2 times 180. So it would be 3 times 180. 540.
Okay. Now what?
540 divided by 18? No, that won't work.
Actually, that will work. That's a shortcut. Now, you notice you got the 18 by totaling all of those.
Yes.
I like that. 540 divided by 18 gives you 30 degrees. So what's the smallest angle?
60.
Good. That's actually a nice shortcut. Because the other way we were going to do it was 2x plus 3x plus 3x plus 5x plus 5x equals 540. We end up adding those up. We got 18x. So you do the same thing, but it was a good shortcut. Can you read all of these? This is x plus 1, this is x plus 4, this is x plus 3, and this is x plus 2.
Okay. So the area of ABCD, so I would say x plus 2x plus 5 equals 100.
We're talking areas here.
Oh, area, not perimeter.
Right. Okay. I think we're going to have to multiply that out, because the bottom one is this, and you can't assume that it's the same, or can you? Let's see. Let me think for a moment there. No.
Does it matter that we have 4 and 1 on the one, and then 3 and 2 on the other, so they're both equivalent to 5?
Well, if we could certainly say the perimeters are the same.
Okay, but not necessarily the area.
I think not, because if we multiply these out, notice that this is x squared plus 8x plus 4, and this one is x squared plus 10, excuse me, plus, hold on. Let me go back and remember how the heck to FOIL. This is x squared plus 5x plus 4. This is x squared plus 5x plus 6.
Oh, okay, so we know the plus 6 would be larger.
Yeah, but they want what it is.
Okay, so
this is not so easy. There must be a shortcut to this.
I know, and I'm not seeing it.
No, I'm not really.
That's all?
Well, if I compare this, now I see it. If I compare that, what is this equal to? If x squared plus 5x plus 4 equals 100, what is x squared plus 5x plus 6 equal to?
98.
2 more,
Oh.
not 2 less.
Okay.
102. I like this problem. This is a nice problem.
Yeah, that's a tricky one.
Well, notice how much work is involved in solving it. Let's see. That's going to be x plus...
That's what I would have done, is I would have solved for the x. I would have completely gone through the whole thing.
Well, how hard is this? This is a pretty hard quadratic to solve.
It is.
This one's a little... isn't that easy to solve either. Are there factors of 16 that subtract to 5? I'm trying to think of what they would be. 30, no.
96 divided by 16 is 6. Yeah,
I don't think that solves nicely. I don't think that solves at all.
Uh-uh.
In fact, you'd have to use the quadratic formula to solve that. Probably the bottom one also. That's why I like this problem so much, is because the only way to really solve it is not to solve for x, but to solve for x squared plus 5x. Notice that's really what we're doing. If x squared plus 5x plus 4 equals 100, then x squared plus 5x equals 96. And if I plug in 96 for those two, I get 102.
Okay.
Just curious what the book says for this one. I don't have the book anymore, but I just have these pages. Yeah, they do it the shortcut. And that's the only way they even suggest doing it. Okay. Refer to a rectangle which the length of each diagonal is 12, and one of the angles formed by the diagonal and a side measures 30 degrees. Okay?
Okay, so it's going to be a 30, 60, 90.
Hmm?
And the area is length times width. Or I'm doing triangle. So it's going to be in the ratio of 1 root 3, 2. So the length would be 6.
Hold on. What's our ratio? What's our scalar ratio or our linear ratio?
1, oh, I was doing 1 root 3, 2.
Okay, always make sure you're dealing with the right sides. What's the only two sides we know that are the same?
Okay, well, I know the hypotenuse is 12.
Right, and this hypotenuse is 2, so when I say what's the scalar ratio, I mean 6 to 1.
Right. Oh, okay.
Okay, because that's always your first step, is to determine what the linear ratio is. And by linear ratio, the linear ratio is different than the area ratio. The area ratio is not 6 to 1. I can't say that this triangle is 6 times bigger than this triangle.
No, I was just saying that one side was 6. Okay. I was saying one of the sides was 6, the other was 12, and then the other was going to be 6 root 3.
Okay. Yeah.
Makes sense?
It does perfectly, and I'm completely with you. So this side is 6, and this is 6 root 3. I just wanted to make sure you're doing that first step.
Okay.
Which is dividing 12 by 2. Because that's an easy step with this triangles here, but make one of these square root of 2, and all of a sudden that becomes a difficult step.
Right. One
that's very necessary to do precisely, finding that ratio as your first step. Okay, so what is the area of the rectangle?
It's going to be 36, well, it's going to be 6 times, let's see, 6 root 3, half of that.
Hold on.
So it's going to be 18 root 3.
Why is it half of that? It's the area.
Oh, I'm doing the
triangle. Right. The rectangle is the full length times the height. So it's 36 root 3. Okay. And let's see, what's the perimeter of the rectangle?
It is going to be 12 plus 12 root 3.
Which is C. Okay. It's 10 o'clock. Why don't we end it? We almost got to 8. We're almost, but there were 25 questions in this last section, so we had more to do today. We actually did more problems.
And we did a lot.
Yeah, I think geometry is going to be your strong suit. So.
Oh, good. I hope so, because it seems like they have a lot of geometry in there.
Well, good.
And
I think there's only 3 or more sessions to go. There's quads and there's circles. And that might be it. Good. And then, of course, there's a full practice test. So we still have plenty of material, but it's getting smaller. We've covered a lot of this whole book.
yeah, now if I can just retain it all.
Yeah. I think you're doing pretty good at it.
Well, thank you. And in fact, I was going to let you know, because going over the recordings, I know I sound like a complete total idiot. And just to let you know, I did take one test and I got 167, a score of 167 out of 170 on the math.
Wow.
So although I sound like a total idiot while we're going over this.
You don't at all. I mean, self-judgment is always the hardest, but it's like, I remember when I was a kid, the very first time you listen to your voice on a recording, that's not me.
I know.
That can't be me. So, no, I think you're doing fine. And
Well, thank you. Thanks to you.
You'll do well. All right.
Okay.
Angela, I will talk to you, let's see, it's tomorrow, right? Yeah.
Tomorrow, yes.
Now, tomorrow's July 4th. Is that fine with you? It's okay with me.
Yeah, that's fine with me too.
Okay. Sounds good. I'll talk to you at 9.
Okay.
Bye-bye.
All right. Bye-bye.